What's next? I don't know if you guys recall, but at the very beginning of the video, I discussed that besides those config files, there are also other configuration files for the build, and these are these config template files. So whenever like you already have defined how your layer and kind of like all the ecosystem in terms of software you added behaves, but now you need to tell Yocto how to build it and where to find stuff and what to make use of, like, right? So that's what we're gonna be doing here in a bit. We're gonna be creating template files. um, there are two specifically, there are two files that Yocto uses in order to determine how the build is going to happen, right? So if you're going to be defining that, like if and those two files are named bb layers conf and local conf. So bb layers conf is a file we're going to, like if you guys see here on the wiki, so this file bb layer conf essentially just tells Yocto which bb layers to use. So baby layers are just Yocto layers, Yocto meta layers. So it is not enough with just kind of like cloning the meta layers into your local system. So Yocto is not gonna be, a magical thing that is gonna go and look for the files or look for what layers you have available. You actually need to tell Yocto what layers you have available for this build, and this is where you do so. So it's very simple. This, like, the structure of this file is super simple. It's just telling Yocto where to look for the layers that you have. Okay, cool. Now, the other config file is the local conf file. And this essentially is just a local configuration file that will define some environment variables that Yocto will use to build your system. Let's use this example. In here, they are defining, like we're defining the machine. So let's say, like in this case, we're building for ProventusNova Jetson Orion X16 dev kit machine. Then we're also defining the download here. This is where Yocto is going to download all the resources. This is very important to define because, like, Yocto is gonna be downloading a bunch of stuff, all the source files for Linux, all the source files for any package that you want to install. It's gonna download, and as long as you download them into a specific file that you're not gonna change later, Yocto keep tracks of that. So whenever you're rebuilding your image, like the first time, it might take a bunch of time. Like the first time you build Yocto, it might take hours. But then after you build, Yocto already knows it don't, like, it has already downloaded all the files, so it just kind of goes and looks there. And the same goes for the state cache file. So the same thing is Yocto keeps track of everything, so it has a cache, and then it will go look into that cache for understanding what's the current status of different packages you already built. So that's very important to have defined so that you can make sure that you're not kind of doing this over and over again every time you build. So important to have there. And then it defines a temp there. That's where it's gonna build everything into. Then it defines the distro that we're gonna be using. So if we have multiple distros, with different features, for example, you can choose that here. And then a bunch of other stuff like package classes, submat SDK machine. There's a bunch of different stuff that we can define here, and everything changes depending on what on what kind of like meta layers you're gonna be using, what the machine, like what the system you're gonna be using is. Like, depending on everything, you might have even different environment variables to define depending on what layers you have, and so on. So let's go ahead and do the same the same thing. We're gonna go into the MediaTek repo. This is gonna be kind of our we're gonna be basing off. So let's go here and look for some template files that we just can copy over and modify them so that they accommodate to our custom build. So let's go here. I'm sure. Okay, so yeah, in the BSP they have config files, so they have the bb layer conf sample and the local conf sample. So we can just see that and see if that's gonna work for us. Okay, one thing that we need to take into consideration here is that we are on Kirkstone, so we might need to go ahead and redo the machine. Let me just do that very quickly. So let's go into machine. Let's do the actual branch that we want to use, which is really scarf gap B25. So this is kind of like this is the tag that MediaTek suggests everyone syncing to, right? So let's go ahead here and look for, let's yet again just look for G510 VK. Kind of refers to this file. I'm just gonna make sure that we have the proper things instead of something that's outdated. So I'm just gonna copy this, and I'm gonna copy it here. So I'm gonna just replace all that. So yeah, it seems like something changed. They added driver for external I2C device. So that's cool. Let's go ahead and fix that on the Git real quick. And they also changed this. It seems like MediaTek G510, G510, EVK, GVT. So the device tree changed, and they also changed. This they added support for the external I2C device. So that's very important. Let's go ahead and add that. So we're gonna do git status and git diff just to make sure that the diff looks good. Yeah, cool. So git add dash u and then git commit amend because I don't want to redo the same kind of like a tiny commit just for that little mistake. So commit amend, then we're gonna close that. Okay, cool. Now we're up to date with that. Cool. Now let's go ahead and look into what we were doing. I already forgot. Yeah, we were doing the conf. This is scroll cap. Okay, so it seems like I don't know if you guys recall, but we were trying to see the templates here on the MediaTek VSP, but seems they removed them from here. So let's go ahead and let's go look for them. I'm sure they are on the demo repo. So we'll need to we'll need to go to ready, and we'll need to go to meta ready. That's where the meta demo is, right? So let's see meta ready demo. Let's go ahead and sync once again because every time we switch from repos, this is reset. So I'm gonna go ahead and look for the proper branch. We're gonna go into conf. Okay, we didn't have that here. Let me try to find that for you guys real quick. Recipe support, recipes demo. Okay, let me see where else. So maybe in meta conf. Yeah, templates default, templates mention. Okay, templates default. We have them here. So templates default. I think these are the ones that they're using. We can just verify that very quickly by coming here and see what the commands they use for this are. Okay, so they're using this is the templates. We're gonna go through these steps in a bit whenever we start building. But for now, let's just go ahead and see what they're doing here. So what they're doing is they're doing template conf project root. Then they're looking for meta ready meta conf. Meta ready meta conf, and that's exactly where we are right now. So we are in meta ready meta conf, and they're using these templates right here. Templates default. So we can just replicate that really quickly. So we can just go ahead and do BB layers conf sample. So let's do. Okay, let's create the templates directory here in this in conf, right? I'm gonna go ahead and here in conf, I'm gonna just go ahead and create a new folder. I'm gonna call it templates. And then instead of the templates directory, we're gonna call one default. Okay, we can change that later, like and have different templates for different layers. So we're gonna do templates default, and then we're gonna just come here and copy this BB layers config file. So I'm gonna go ahead and do new file. I'm gonna call it BB layers conf.sample. So I'm gonna copy this because I'm too dumb to remember that. It's a new file. Boom. Okay, there you go. Cool. Now we can use this right here. This we might need to change later because depending on what strategy we use and where we're gonna be putting the meta layers, we're gonna require to change this, right? But for now, this works. Okay, cool. And we might want to remove a bunch of meta recipes from here, like meta layers from here, because they might not make sense, but we will see. Okay, and then let's do the local conf file. So we're gonna come here, do the full new file, local.conf.sample. I think local conf sample. Yeah, there you go. So this is the local conf sample. This is the layers. Oh, sorry, this is the BB layers conf sample. And then let's look into the local one because there's a bunch of comments that we might want to remove. So here, for example, we're gonna remove this. This is all kind of, explaining how everything works. We already understand that. So let's go ahead and change this for our machine. Do you guys recall? We have now a machine, so we need to add ours here. So MTK G510 conf. So we're gonna name this, or we're gonna change this for. And well, we're gonna do is this. We're gonna just remove this machines here. We're gonna change this for our machine. So MTK, MTK G510, and the conf you don't need to add. Where to place the downloads. So this is allowed the downloads directory. What we're gonna do is just leave it there, top tier downloads. That means like whatever you run the bitbake command on the top tier, use that, right? Cool. Where to place the share files, the same thing. Where to place the build output, so the temp, we're gonna do that. That works too. So let me see. So download here, downloads. Let me see what they do here, because I recall they might just kind of change it for them. So they export build here, pwd. Okay. Okay. Yeah. So let's change this so that it's like that. Right. So we do want to use top tier state cache, top tier downloads, and we also want to use top tier temp. I think that's how we define it here also. Let me double check that real quick. So we go here into the and the down, yeah. Oh, okay, yeah. So we're doing top tier downloads. So top tier downloads. We'll need to see what top tier is actually there, because I don't quite recall. But we can definitely leave it there for the time being. So we can do okay, cool. Yeah, for the time being, just leave it like that. And then default policy config, they use ready demo. But what we're going to be doing is changing that, because the policy config that we're going to be using is bnmtk. Okay, we're going to remove this. And then package manager and configuration. So this is like you can configure Yocto. Yocto is so cool. You can configure it to choose which package manager you want to use. In this case, by default, is IPK. IPK is recommended for embedded devices. It's kind of like a more streamlined package manager, but you can even add multiple. Like for example, you can even add Debian package management. So you have Yocto not only building the IPK packages, but also building Debian packages, which is very useful. Also, like if you wanted to have custom Debian packages be created for from your build, so that you can later install on user space, you can definitely do that too. So yeah, just kind of take that for what it means and do whatever you want with that information. But yeah, you can change package manager if you want to use other stuff. The soup machine, this is for the x86, but we're just gonna remove. Okay, so we can just leave it like that. And then image configuration defaults. So this debug tweaks is for enabling you to access, to log in into a board without you having to use a user and a password. These are other kind of like extra features you can add, but you just kind of leave it like that. Just gonna clean it out a little bit. Then additional image features. Okay, so build stats, that's cool. Runtime testing of images. This is if you were gonna be using a kind of like an emulator for testing. Like for example, this is for QEMU, but we're not gonna be using that. That's why it's commented. We're just gonna leave it there if someone else wants it. Depending, like if I were building this for a customer, I would remove everything that's commented, because if it's commented, it's not used, and if it's not used, it's not required. If not required, it's just kind of like taking space there. But since this is going to be used by you guys on different projects, you might actually need it, so I'm just going to leave it there. But take that for what it means. Like if you want to do your own project and kind of keep it clean and tidy, I would suggest removing whatever is commented, because not used. If it is not required, better not take space. Okay. Yeah, so that's it. Then we're gonna see this. I'm gonna remove this. Okay. Disk space monitoring. So yeah, that's cool. I'm gonna change this here. So remove that. And then yeah, same here. And then same here. this is the mirrors, right? Like whatever you want Yocto to go and pull stuff from. So you can modify to this QEMU configuration. Gonna leave it there, comment it out, just as I mentioned. It might work for some of you guys. And then this is the sanity check, hash equivalence. Once again, like if this is not used, you might just want to remove it. And then memory resistant bit bake. Let's see, what does this say? So the components stay in memory after UI. Okay, yeah. So you can just leave that commented, like not needed. Conversions increase. So this better not to play with unless you kind of want to mess stuff up. This is gonna go ahead and match with the rest of Yocto. And if it doesn't match at some point, it's just gonna break and it's not gonna build. So just leave it like that unless you really have a reason why to change it. Okay, licenses. I'm gonna just leave it as commercial, but you can change that. Like in this case, it's commercial, but then you can just maybe, I don't know, you just want to use MIT licenses on your project. So if you change that here, then later whenever you're building, Yocto is gonna go ahead and check against this all your packages. So if some of your packages are not kind of like within this specific commercial license, for example, requirement, then Yocto is gonna let you know. It's gonna kind of break, right? It's gonna explode in your face, and it's gonna tell you, "Hey, man, you're trying to use a a package that doesn't match the license requirements that you have in your configuration file. So we're not gonna continue from here. You need to decide whether you need to whether you want to allow that license or whether you need to change the package." Okay, cool. Now, this is connect to a board by default. Okay, this is the host name. You can leave it like that or later change it if you want. Image of types, so tar. Okay, you can change that here. This is like how you want to package your images. Okay, this is kind of like the default, but you can change this if you want more space. For now, we just leave it like this, and later we can kind of like enable more space. Like for example, the dev kit actually has a bunch more space than this, so you can enable that if you want. Yeah, I think it's 64 gig. I need to check, but I think it's 64 gig, and this is just kind of like 2 gigs, I think, or something like that. So it's not great. Or 20 gigs. I don't know. I forgot, but we'll need to check. Uncommon to enable multi-lib support. Okay, blah blah blah. Device tree overlays. Okay, this is cool. This is the device tree overlays. So if you want to enable stuff, you can come here and add the overlays, right? So, for example, if you had a camera, right, I don't know, overlay, you can come here and enable it. If you can see here, we have for the Genio 350, 700, and 1200, but since we're using just a 510, we're gonna remove those and just leave the overlays that we want for our platform. So we're gonna be using the video DTVO, the APU sys DTVO, display DTSI DTVO, and HDMI DTVO. Cool. All right. Let's see what else we need here. So I think that was it pretty much. And then yeah, we will need to go ahead and like we will need to return and figure out this once we decide on what strategy we're gonna use to clone the other meta layers, because there are a couple. Like for example, you could use just Yocto Git sub projects and have all the meta layers in there. You can just kind of have them being cloned and maintained by Git and all that, which is very cool. And you can also use something called a manifest. That's how MediaTek does it. We will see. We might do it the same way they do, just to keep everything the same. But I'm not completely sure, since I don't want to be maintaining that separately. So yeah, we will see if we can maybe. And also, one thing that I've noticed is like if you wanted to later add some sort of CI, pipeline to your Yocto build, with the manifest, it gets a little bit more complex, because you will need to kind of like pull everything, and then like you will need to use the manifest. So you will need to install the tools for the manifest, and then you will need to use the manifest file to pull everything in, sync against that manifest, right? So it gets a little bit more cumbersome. Whereas if you just use the kind of like the Gitsu modules, right? You essentially will have everything within your build machine right there available for you to build. So integrating Circle CI into this with some modules is a little bit more easier. So we might just go that route. in order to later do a tutorial on how to do circle CI, which I'm sure most of, like some of you guys might be interested. So let us know. Let us know if you guys want us to cover both cases. Let us know in the comments so that we can create another video, just kind of like covering the two different ways of keeping track of this, keeping track of other meta layers we are using, or yeah, or we can create that video and let you guys know. But yeah, just let us know in the comment. Cool. All right. So we're trying to do. Okay, so we're done with this. Well, I think after this, let's go ahead and just read our wiki here real quick. Because after write this, okay, we add the image recipe, and then we can create layer via bitbake. All right, create layer. Okay, this is another method for creating the layer. Okay, so next is just adding the basic image and then trying to compile. So we can either do that, or we can either do that, or we can go ahead and try to build and just build a different image and see how that's gonna work. Now, the only reason why I'm hesitant about kind of like pushing this or just committing this and then moving to the next task is because I need to think what's gonna be the best strategy. So let's think. So like the thing is this: if we want to use submodules, we'll need to determine whether this is gonna be the path for the meta layers or not, right? So let's see if we want to use. So what? Okay, let's go ahead and check what they're doing here real quick. So if you see the instructions from MediaTek, what you guys will see is that they recommend using repo. And this is one way of keeping track. I don't know if you guys remember, but I mentioned that since Yocto is an open source project, you will pretty much constantly be having constant changes on the Yocto sources, right? Which is not great. Like you might imagine that, or you might think that it's amazing because you will have kind of always up to date things. But the thing is that changes don't always work, right? And this is kind of like one of the downsides with Yocto is like if you have a very stable Yocto image and then someone else comes and push something into Yocto that then breaks your image, then you're not gonna be happy. So one thing they need to do is keep track of all the layers that you're going to be using to like to a very very detailed specific version of, like, for example, up to a commit, essentially. Like if you build your latest release and you use certain commit, then you know that that is the commit that you're going to be using. You freeze that, so you freeze that in such a way that later if someone else tries to replicate the build, they're going to be using the same commit, so that it's not going to break on production, right? That'll be very critical. So there's a couple ways of doing that. The way that they do it here, MediaTek, I mean, they do it with the repo approach, and the repo approach is pretty cool. It's actually pretty well known for in kind of the Yocto community, and it is a tool by Google called Repo. And Repo allows you to create a manifest file, which is an XML file where you define the kind of like the repos that you're going to be using. So and that's Git repos, so you find the Git repositories that you're going to be using, so the Git repositories where you're going to be pulling your meta layers from, and it defines what commit that you want to use or what branch you want to use, so you can sync them all to whatever you are actually comfortable with using. So what we can do is just go here, and this is the manifest file they use, right, on the MediaTek side. So this is the manifest file. Let's go ahead and once again, because the manifest needs to be synced with this specific branch. So what we're gonna be doing is we're gonna come here, tag it, or kind of like sync it to the tag that they're using on their wiki, just to make sure that we're using the latest one. And we're gonna take a look. So this is what I meant, right? This is a configuration file or the XML file that the manifest uses in order to pull everything and sync it to a specific version. So you can see here that some of them they are syncing just to a specific tag, in this case here, or there are some others that are even being synced to a specific commit. And you can do that with all the projects. You can since as you can see here, there's a bunch of different meta layers that they require for building their demo layers or their demo images. So let's go through them real quick. So they have this that are synced to this specific tag are theirs, because that tag, that that git tag is theirs. The release card gap v250. So these are repos that we should be able to find here in their git directories. So for example, we have MetaReady. We already kind of like dig around that. MediaTek BSP, we already also play with that one. That's where we got our machine file from. Then we have the MediaTek TSN, MediaTek demo. That's also another one we know. And this Blue Droid one. And then they have these other ones, the Meta That's for neural network stuff. And they have Pokey, they have ARM, Open Embedded, TensorFlow, Security, and this Metacilan one. So we'll need to decide whether we want to use this manifest version, or kind of like this manifest approach, or if we want to go with the Git submodules one, because with Git submodules is more like they do it on NVIDIA. So if you go here and you check, for example, MetaTegra, let's go there and see. Oh no, MetaTegra, no, let's go and see Tegra demo distro. That's the name of the. So if you go to Tegra demo distro, which is their kind of demo distribution for NVIDIA, you will see that what they do is they use Git modules. Like there's no repo here. What they do is they have this repos directory where we have all the submodules. Granted, there's less submodules in this build, right? And on the MediaTek one, but doesn't mean that we can do the same. The good thing about this is that, kind of like as I mentioned, integrating this with CI is a little bit easier, at least from what I've experienced. But we can do both. And in this case, I think I'm gonna just go with I don't know. What would you guys think? Because if we go with the repo side, like the best practice is to create another Git repo just to host the repo, the manifest, just as they did here. This is a specific repository just for the manifest. So that's one thing we can do. And the other is just kind of like to have them be submodules, which should also be very simple, which is just kind of like us creating the repos directory in our local clone of our repo, and then we would essentially just clone all these repos and match them to a specific revision, and then we'll have Git take note of that in the Git repo stuff. That's good. Let's do it like this. Screw it. Let's do it the Git way, just so that we can later do circle CI integration the way I know how to do it. Maybe you guys know a different way, and later using repo later, and you can teach me. That's the beauty of the internet, right? So let's go here and say, okay, so let's do Git status, because we have some changes there that we haven't done yet. So what I'm gonna do is I'm gonna just leave the changes there, and let's do, so we have conf file. So let's go ahead and check once again MediaTek demo. So what they do is they have here the repos, right? And then they have a layers one. That's where they have the meta layers, but we can just leave it like that. Or maybe we can just create here the M. So let's create a directory called repos. Just to kind of do a quick recap of what we were doing before we jump into that pause. We finished up doing the templates. We have them here, the BB layers template, and then the local conf template. And we were gonna be deciding on what we were gonna do with the other meta layers were gonna be important, right? Because here in the BB layers conf, what we're gonna be defining are the meta layers that we're gonna require on a Yocto build, right? So not only our layers here, right? Because we have here meta P and MTK, but we also need other meta layers to be able to build a Yocto image, right? Remember, Yocto is like an onion, so you need a layer upon layer upon layer so that you can build your system the way you want it. So yeah, there's a couple ways we can do this. If you guys remember, there's the repo manifest one, and then Git some modules. Either way will allow us to actually freeze our build and all the meta layers to a specific git commit hash, which makes it very easy to maintain, and then also makes sure that if we rebuild this on a different environment, on a different computer or something, it's not gonna break because some random people, are committing stuff into meta layers you guys are using. So this is very important. We're gonna go with Git some modules, mostly because this makes very easy to integrate with GitLab, with Git CI. So if you want to automate it, like to automate building your Yocto images on GitLab or in some sort of CI, pipeline type of framework, in our experience, that's the way we've done it. So we're gonna do it this way, and then if you guys want us to do it a different way, like with repo instead, just let us know down in the comments, and we can definitely jump on and do a video on that. This is even like this might require a whole video on its own, but yeah. So before we do that, actually, since I already recorded this a couple times, I know beforehand that we're gonna hit an error. So let's go ahead and fix that, because that's gonna be a little bit more clean on our Git history. And that error is actually with our machine. It's a very simple error that is gonna stop you guys from building. So pay attention to this, right? So if you hit an issue where once you start building, where this where the machine is not building because of this includes, this is the fix to it. So pay attention to this, and we're gonna avoid that issue right from the get-go, right? So the issue here is essentially that since we're including MT8370 and MT7921 from MediaTek's meta layer instead of ours, we cannot include that as if it was local to us. So we need to include this with conf machine include, with conf machine before the include part, right? So that Yocto is able to find this in the kind of like the global Yocto environment, instead of trying to look for this locally in our meta layer, because it's not gonna find it. So that's all. That's the fix. Cool. All right. So I'm gonna go ahead and push this. This is why I rather do it at the very beginning, is because it is very easy for us to do. For example, if I do a git log real quick, sorry, git log. So git log real quick will show us that the last commit was actually at base machine. So we can very easily just amend this commit so that it has now the proper machine configuration, and Git history is going to be nice and tidy. So I'm going to go ahead and do git add, right? Well, git status will show you that we only have a modification. So if we git diff, it'll show you the small change we did. So I want to do git add -u for just kind of to add the on stash stuff. So I'm going to do git status once again. Oh, the on stage stuff. So yeah, that shows that now we have staged our change on the machine configuration file. We're going to do git commit amend, right? That is going to fix our add base machine commit. It's going to ask us for the password. That's because I have set it that way. And yeah, that's it. So we already have fixed our machine. We're good to go. So let's go ahead and start adding our repos. If I'm going to do, if I do an ls, all we have is the configuration directory where we have all the configuration for our custom meta layer, and then we have the readme. What we need to do here is actually just add a new directory where we are going to be storing our repos. I'm going to name that directory repos, right? Super creative. All right, cool. So let's go ahead and do mkdir, right? For make directory, we're going to do repos. We're going to be storing everything, like all the repos we're going to be getting. All the submodules are going to be stored there. So let's go ahead and do that. The way we get the submodules is very simple. So we go to the default XML manifest here from MediaTek. Remember to set the proper branch. Where you can get this very easily, you just go to MediaTek's Wiki, and if you find where they start counting the configuration for everything, they get you here to sync kind of like your build to this Git repository, which contains the manifest, and then they require this repo to sync it up to this branch specifically. So that's what we're going to be doing. So we go here, right? This is the repository. It's already synced to that ScartGap branch, which is very important. And then this manifest, if you guys see, is just an XML file which contains all the repos that you're going to be requiring for this build, or at least according to what MediaTek requires you to have, right? At least to build their demo image or their demo meta layer. Plus, it's gonna specify the specific versions. There are some repos in here that are gonna be kind of like revisioned by a branch or a DAC, and then there are other repos in here, like for example this one, which is actually revisioned by a git commit hash. So if you see here, like this is very, very cool, because like for the commits that you're gonna be revving or kind of like freezing to a specific commit hash, like there's no way someone will go and push a new commit and it's gonna break your build. Because every time you build and you use this, it's gonna sync it up to that specific commit hash that you know it works, right? So that's what's cool about Git. And then for the ones that actually use this other way of syncing, it's not a branch, it's actually a tag. So that's very important, because the difference between a branch and a tag is like once you tag something is tied to a specific commit. If you use a branch, then you're also vulnerable to someone else pushing to a branch and breaking your build. So using a commit tag is better. Since these are commit tags, because we already know from the work we've been doing, we're completely fine. So let's go ahead and start adding the commit submodules. Well, the git submodules, they're actually very easy to add, but I forgot the command. So I'm gonna just go ahead and Google here real quick how to add submodule, because I forgot. I think it's just git submodule add, and then I think it's just git submodule add, the submodule and where you want to add it. But let me just find something to reference of to use as a reference. So here, for example, this is git submodule add, then the kind of the link to the repo you're gonna be adding as a submodule, and then the location, right? So we now know that this is gonna be repos for us, and then whatever name we want to use for that specific submodule. So this is gonna be very repetitive. We're gonna go ahead and start. Let's go ahead and do first the if you you can see here on the remotes you have multiple definitions. So you have one for READY, one for Yocto, one for Open Embedded, and one for GitHub. So READY are the ones from MediaTek. The other ones are very much just Open Embedded stuff. So we're gonna start with the Yocto ones, then Open Embedded, then GitHub, then we can do READY, which are the kind of like the more custom ones, right? Because it's custom to your to the boards that we're gonna be using. So that's just a nice order to follow, I guess. So yeah, let's go ahead and do that. So really fast, what we're gonna be doing is I'm gonna just Control F here this for just to make it easier on myself, and then we're gonna start by copying or by cloning Pokey or adding Pokey as a submodule. So this is gonna be very simple. I'm gonna go ahead and copy the remote, sorry, here. So I'm gonna copy the remote, Control C. So I'm gonna go here, and then I wanna do, well, let's see, we already created the repos directory, very important. So I'm gonna go git submodule add, then the remote, then / and I'm gonna add here the name of the repo, right? This is the name of the repo. It's gonna be pokey.git. So I'm gonna copy that, paste it here. Then I'm gonna specify where I want this submodule to go. So I already know that I want this to go inside repos, and I want this to be named Pokey, right? I don't want to change the name of the repo, of the GitHub repo. So I'm gonna go ahead and run this. Let me see, locally with remotes, origin. Okay, so this is mostly because I already added this before. So yeah, this is not gonna happen to you guys if you're gonna be doing this from the first time. This is just because I'm doing it, kind of third time now. So I'm gonna go ahead and just force it, so that we reclone everything and you guys can see. But you should be able to run it without the force parameter, right? So I'm gonna do force. What's that? So I think I need to add this in the git submodule, add --force. Nope. How's it that we use this? Let me learn this real quick. So use the force option. So I guess it goes here. Git add -- force. There you go. So now if we go into repos, Pokey, I do ls. So we are already here, and you see, like, this is already detached at the commit hash. That's because Git history already knows this, because I already did this before. So what I'm gonna be doing is I'm gonna go ahead and redo this for you. If whenever you clone this, probably it's gonna be like something like this. It's gonna be checked out to master, for example. So it's gonna be checked out to master. It's gonna look like this, right? It's gonna, like, if you do git branch, it's gonna show that's on master. And then what we're gonna be doing is actually making sure that we match or that we sync it up to that specific git commit hash. So I'm gonna copy this, I'm gonna git checkout, right, the commit hash, and so it's gonna say that blah blah blah, we're gonna be detaching our head to a specific commit hash. That's okay. So I'm gonna just do that. I'm gonna go back, then I'm gonna go git status. Let me see what changes, what changed here actually. So yeah, okay, cool. So now I think if I go back, let me see, ls dot. So now we have actually, it gets some modules. And see, we have Pokey here. All right, so I don't know why was Kit complaining before. As I mentioned, that was because I'm already doing this for kind of like the third time, so that's normal to me. But for you guys, it shouldn't be that way. But like either way, you see that if it happens to you guys, you can just use the force option right before, right after that, and it should work regardless. So I'm gonna go ahead and continue adding the other repos here. So the next one is gonna be meta arm git, right? So we're gonna do just the same. We're gonna copy here this part. We're gonna go ahead and do let me look for that command. So it's gonna be something like this. Probably it's gonna require the force, so let's just try it for fun, right? And we're gonna change pokey.git for meta arm git, and we're gonna be cloning this. Is instead of pokey, we're gonna be cloning into meta arm. So if I run that, so same thing, it's gonna require the force. I think I'm just gonna use the force either way on all the from now on, right? So if I do force, then it reactivated the modules there. If I do ls, if I go into repos, I should be able to go into meta arm, and we already synced to that specific commit. If you see here, that's because I already did it, but you guys need to actually do this, right? So git checkout, the commit hash, it's already there. So go back, then you go once more back until you are on meta pnmtk, and you run the same command for the next repo, right? In this case, it's gonna be meta tensorflow.git. So we're gonna look for that handy dandy command, right? And we're gonna be pasting, instead of meta arm, we're gonna be using meta tensorflow git instead of meta arm. Here it's gonna name meta tensorflow, right? Then we're gonna go into repos, meta tensorflow. It's already synced to this commit, but for you guys, it's not gonna be synced there. It's gonna be synced to master or something. So make sure to run git checkout the commit hash, right? It's already attached there. So we're gonna go back and then go back, and then we're already here. So we're gonna do the last git repo for Pokey, which is gonna be meta security. Oops. Okay, so meta security. We're gonna look for that specific for the git modules add command. We're gonna change meta tensorflow.git for meta security. Notice that in this case it doesn't have .git. That's okay. That's how the repo is named. It works for us either way. So we're gonna rename this to meta security. We're gonna go into meta security. It's already synced to BZ865C5. So this is right here. So if you guys see here, it says BC86, so it's already synced there. That's because I already did it. Once again, you guys just need to do it. It's just git checkout the commit hash. You're good to go, right? Cool. All right, so that should be it for the Pokey repos. Now let's go ahead and do open embedded. I think this is just going to be one or two. Oh yeah, one. So that's very cool. We're just going to go ahead and copy this remote. So Control Z. Then we look for the git module add command. We paste it here instead of the Pokey remote, right? We add a /. Then we look for the name of the repo, which is going to be meta open embedded, right? That is very important. Then you're going to place it here. Then instead of meta security, it's going to be meta open embedded. So it goes ahead and reactivates it for you guys. It's going to clone the repo and all that. So if I go into repos, meta open embedded, it's already synced there. So I'm going to just go ahead and redo the git checkout, right? And that's good. So I'm gonna go ahead and cd ls. So we are right there, and then we just need to do the GitHub one, which is just one. Once again, I just can like copy here the remote link, right? Look for the submodule command. Let me try to find that. So here I just delete what was there. Oops, I messed that up. So yeah, remove the open embedded one. I'm gonna paste the GitHub one. I'm gonna come ahead and copy the name of the repo. Notice this, like this time already changed. Also, it's crash meta clang git. So I'm gonna go ahead and copy that, right? And see how they moved it into meta clang instead of using the the crash or kraj / so they removed that part. We're gonna do the same because this is already accounted for on the BB layers configuration file, so we're gonna be doing that. So yeah, I want to be pasting that here, and right here, instead of doing meta open embedded, we're gonna do the same meta clang. So that's it. I'm gonna go into repos meta clang. It's already there, but I'm gonna do it either way. So git checkout. Remember, guys, this is very important step, because if you don't do this, then it's gonna be synced to a branch instead of a commit hash. So if someone goes and pushes into those open source repos, then your build might break, right? That's the whole point. Like, that's the reason why we're doing this. So let's go ahead and go back, and I think we're ready. We're now ready to actually do the ready ones. So those are a little bit more but it's okay, we're gonna push through them real quick. So we're gonna go ahead and copy this. So Control C. I'm gonna look for the git submodule add, right? I'm gonna remove the remote, add the ready remote, and make sure that we start doing the repos one by one. So I'm gonna start with meta ready. I'm gonna go ahead and paste it here, meta ready. Instead of meta clang, I'm gonna do meta ready, right? Then I'm gonna go into repos meta ready. If I do ls, I already have everything here, right? Because GitHub is already syncing it up. But just as I've already mentioned a couple times, you guys need to actually sync this. So the way you do that is you just go ahead and sync it to this tag, I think. So you just go ahead and do redis cargap v250. So Control C, right? And do git checkout redis cargap v250. Right, so it's already synced there. I'm gonna go ahead and do the other ones real quick. So it's gonna be meta MediaTek bsp.git, right? So copy that one up, look for the git submodule add command. I'm gonna remove, oops, I think I removed too much of it, so I'm gonna go ahead and redo that. Oops. Git add force. So we need to recopy the remote because I don't know what it is. So I'm gonna just copy that, paste it here, right? No biggie. Ready / then we go ahead and copy meta MediaTek bsp git, right? We paste it here. It's gonna go ahead and copy that. I'm gonna do this just fast because I already have them, guys. But well, I'm just gonna do it the right way. So I'm gonna go into meta repos meta MediaTek. What's the name of it? Oops, I think I messed that one up, because do you see, guys, that right here? I ran the command but didn't change the repos meta ready, so I forced cloned my MediaTek bsp into meta ready. So that's an issue. So I'm gonna go ahead and redo that. So I want to go ahead and try to fix that. So I'm gonna run this, right? Because I wanna link once again meta ready to repos meta ready. Then so I'm gonna go ahead and go into repos meta ready just to make sure that we are synced there. So yeah, we're synced to the tag. When I go back a couple times, I want to rerun the meta MediaTek bsp, but instead of repos meta ready, I'm gonna change that, right? That was my mistake last time. So I'm gonna copy this, I'm gonna paste it here, and I'm gonna remove the .git. So I'm gonna be cloning meta MediaTek bsp into meta MediaTek bsp, which makes sense. So I'm gonna go into repos meta MediaTek bsp. So right there, it's cargap v250. Cool. I'm gonna run the command to sync it up just in case. That's okay. So git checkout, boom, that works. So I'm gonna go ahead a couple directories up, and then I'm gonna look for the next one. So the next one is actually meta MediaTek tsn.git. So I'm gonna copy that. Once again, remember to change this. That was the issue last time. And then I'm gonna change it here too. It's here. There you go. See repo meta MediaTek TSN. It's already there. So I'm gonna just go ahead and run the git checkout to the specific tag, and go back a couple times right here, and then I'm gonna do meta MediaTek demo git, Control C, right? Git some module, change this, then change this real quick. There you go. CD repos should be here. Then if I run the git checkout, it's already gonna be there, but it's okay. I'm just running for you guys so that I can feel the pain. But yeah, so I'm gonna go ahead and copy the next one, which is gonna be MediaTek Blue Droid. We're almost done, just a couple more to go, and we're gonna be done. We can start building, which is gonna be very exciting. That's the kind of like the best part, right? Of creating your custom Yoctos. Actually have it built and then test it. So yeah, I'm gonna copy this here. I'm gonna go into repos, meta MediaTek Blue Droid. I'm gonna sync it up with the git checkout. There you go. Then we go back a couple times, and then let's do the last two. This is very exciting, guys. Very exciting things gonna happen. And yeah, this is the longest tutorial we're gonna do, I think. And then from now on, we're gonna do smaller ones, but they're gonna be packed with information. So I know you guys are gonna enjoy this very much. Hope you guys enjoyed at least half of what I'm enjoying actually making them. But yeah, so let's go ahead and do this. I wanna this is almost the last one, so I'm gonna change here meta neural network, very important, right? So reactivating cd repos meta nm. I wanna do this is very cool. I can do Control R git checkout, right? That works. So I'm gonna do this. It's already there. Yeah, cool. So I can do ls, right? No, sorry, I can do the last one. Okay, cool. Meta security from Brady. So, oh, well, no, actually this I don't need to do. I already done this. It's just because it is named meta security. It is actually finding it because of the ready. That's cool. So we're already done. Very cool. Now, guys, what we can do is actually, well, we're going to git status real quick. As you guys can see, now we have the modules, and then all the modules cloned and checked out to a specific version that we actually want to use. So what we're going to be doing is we're going to, of course, we're going to be pushing this so that we can keep track of it and our git history. So we're going to do git add, right? So we're going to do git add -u, right? Git status. Then we're going to be doing git commit -m, and I want to add git submodules. I want to assign the commit, right? Then we're going to git status once again. Now what we have are the templates, but what we can do before pushing the templates is actually trying to go ahead and build and see if the templates work. That's going to be the best part. So if I recall, I already tried to do that. So what we're going to be doing, just kind of to recap it, is we're going to go ahead and look for this command, export template conf. This command will let Yocto know where to go and grab the templates from. So we're just going to do Control C, Control V,